Example 2. Okay, it's similar to the last one. It looks like this. And in this case, I have both tangent and secant again, yet I don't have tangent squared or secant squared, so my substitution is going to be different. This is given. Since I don't have tangent squared or secant squared, I'm just going to square both sides. So that gives me tangent theta plus 1 squared equals secant theta squared. On the right-hand side is pretty easy. That's just secant squared theta in our other notation. On this side, I have to FOIL this. Tangent times tangent gives me tangent squared. And then I have 2 of these tangents plus 2 tangent theta. And then 1 times 1 is 1. So that's FOILing that out. A little harder to do without just x and y's, but that's where we're at. And now I'm going to substitute. And from my identities, I know that 1 plus the tangent squared theta equals the secant squared theta. So on the right-hand side, I'm going to plug in 1 plus the tangent squared theta. Okay, now I can just switch to a variable if I want, but I'm just going to leave it. You can do whatever you want. I could use z equals tangent theta, but I'm just going to just solve for this, see if I can do that. I'm going to subtract tangent squared theta from both sides. And the other thing I'm going to do is maybe subtract 1 from both sides. So this goes to 0. That's just 2 tangent theta. That's equal to, looks like everything cancels on the other side. That's 0. Now I'm going to isolate tangent theta. I could just divide both sides by 2. And that gives me the tangent of theta equals 0. Now I might know where that is, but I'm just going to use my table here. I notice it happens at 0, and it also happens at pi, where the tangent of theta equals 0. So on the unit circle here, I might notice where those are at 0 and at pi. And that's what we might sort of anticipated. So my general solution is that theta equals, let's see, 0 or pi, or any multiple of pi is going to work. So I could just say k pi. That's any multiple of pi. That's my general solution. That gets both of those. Okay, last example, example number 3. I have an equation that looks like this. There's both tangents and cotangents involved in this equation. So I want to just relate tangent and cotangent, and from the reciprocal identities I gave you, I know that the tangent of theta equals 1 over the cotangent of theta. I usually like using tangents instead of cotangents, so I probably want to substitute in the cotangent. So I'll just write this down, cotangent of theta. It just says these are reciprocals. So that's 1 over the tangent of theta. So I can use this one or that one to substitute one of these. I'm going to use this one. So that means that I have the tangent of theta minus, and then we substitute in 1 over the tangent of theta equals 0. Now, Just so you can see what this looks like, I'm just going to use this z again because it's sometimes just easier to look at that. So z equals the tangent of theta. So we have, what would this look like? Z minus 1 over z equals 0. How would we solve something like that? Well, we have to clear the denominator. So we multiply both sides by z. So let me add that in here. Distribute. And we get z squared minus 1 equals 0 times z, which is 0 still. And we have this. And we could just isolate z, or we could factor it. I'm going to isolate z, add 1 to both sides. I get z squared equals 1. Square root both sides. Square root of 1 is 1. So z equals plus or minus 1. Don't forget the negative. So what does that mean? That means the tangent of theta equals plus or minus 1. Now before we switch to sines and cosines to figure out what that is, but with the table here, I'm just going to do this. I see in the tangent there's 1, there's negative 1, there's 1, there's negative 1. Let me draw a unit circle and put all these values on there so I can organize this. And you might already know this, but the tangent of theta equals 1 at pi over 4. It's negative 1 at 3 pi over 4. 5 pi over 4, it's 1 again. And 7 pi over 4, it's negative 1 again. 4 solutions on the unit circle. So our general solutions would look like this. Theta equals, this is pi over 4, pi over 4, and since this one is just pi away, it's half a circle away, it's plus k pi. And the other one, theta equals 3 pi over 4, and the other one is cross on that, so I could say 3 pi over 4 plus k pi. I think this is the way they're given in the book.